Okay, so we're on 513, last section of the whole chapter. It's been a long chapter, but this 513 is about using factoring to solve problems. Okay, so we kind of done that. We did that last time, didn't we? But today, guess what? We're going to give you some word problems. Is correct. So it's going to be very similar to what we did yesterday, except that you now have to translate. There you go. We've done this. What? We've been doing this for whole like 4, 5 chapters, right? So we should know. It's exactly the same exact steps. It's just now you're gonna get an equation where it's not linear. It's going to be nonlinear, and you have to use, guess what? If it's nonlinear equation, how do you solve nonlinear equation? You gotta use, thank you, zero product property is correct. So here's our first question. It says find 2 consecutive negative odd integers whose product is 255. Write it down. I'll wait. Okay. So when you look at this problem, again, as usual, we should look for our what, guys? Whenever we have word problems, you got to do the 5-step plan. We got to look for our what's step 1? As you read it, you look for the unknowns. Ali, what are our unknowns on this one? Good. The 2 consecutive, what kind of odd integer we want? Negative. It's kind of different. We haven't had negative odd integers. So be careful. Yeah. Okay. So we're looking for negative odd integers. So anybody know how to declare a variable? Our first, because there are 2 unknowns. Let's use only one variable to represent both. What do we do? Let anybody? Yes. Aaron? Excellent. Let x be the first negative odd integers. Then, if x is the first, remember, how do you represent the consecutive negative odd integer after x? Anybody? One person remembers? 2? That's it. Come on, everybody should know. We've done this many times. How do you guys remember the interesting about the odd and even integers? What's the difference? Stefan? Excellent. Why is it x plus 2, not x plus 1? Because it's an odd, right? So the difference between the consecutive odd integers is by 2, so you write that. Question?
Why is it like x minus 2?
You could do x minus 2, but then you're gonna get the smaller number, right? Like let's say you got negative 3 as your answer. Then if you do minus 2, then you get negative 5. That's going backwards. Don't we want to go forward? What comes after negative 3? The consecutive odd negative integer. Negative 1. Don't you add 2 to that? If it was negative 1, then the next number will be positive 1, right? So then we haven't got, we found the answer, but then there's no solution because, right? Negative times positive would never be positive, 255. You know what I mean? But it's not going to be negative 1 and 1, is it? There's no negative 1 times 1 is negative 1. Yeah, question? That's correct. Very good. Excellent. You already see that? That's awesome. So, you're right. Because it says negative odd integers, it's going to help us figure out which one works. Very good. You already see that. That's excellent. Okay, so then, here's our step 2. Step 1 was to, figure out our unknown. Step 2, we declare our variable. Step 3, we have to come up with the what, guys? We have to come up with an equation. Can somebody tell me the equation? Raise your hand. Yes, Melissa? That's exactly right. They said the product of these 2 consecutive negative odd integers is 255, right? And it makes sense to come out to be positive, right? Because what's negative times negative, guys? Positive, right? All right. So, do we know how to solve this? Yes. Does this look familiar? Didn't we do this last time? Okay. So, what do we do? Could we just solve for x right now? No, it's not linear, is it? So, yeah. Oh, you want to distribute first, or should I make it equal to 0? Let's make it equal to 0 first, because remember we have to use what? 0 product property. So let's make it equal to 0 by doing what, Viviana? Yeah, subtract 255 from both sides. Then you're going to, on the left side, we're going to try to distribute that so that we could factor, right? Because we're trying to hope to factor the whole left side. In order to factor the whole left side, you must distribute that x. Of course, when you do that, you get what, class? Who wants to tell me? How about William? What do I get when I distribute that x? I'm sorry, this William over here. Huh? Uh-huh. Minus 255. And do you all guys, can you then factor the trinomial? Okay, everybody try. I'll wait. Go ahead. You should all know how to do this by now. Thankfully, it's 1x squared, isn't it? It's easy, right? X. Oh, you already have the answer? Oh, hold on. Okay, so I want everybody else to try. Go ahead. Everybody try. Okay, how many ways are there to get x squared? X times x. How many ways are there to get 255? 1, 255. What? Does 2 go in? No, it's not that many. Does 2 go into 255? No. Does 3 go in? Yes. Okay. So 1 goes into 255, right? 2 doesn't. What about 3? How many times, guys? 3 and... Yes, Lucia? Huh? 85. Does 4 go in? No. Does 5 go in? Yes. How many times? Okay. Is that it? What about 6? Does 6 go into 250? No, no. What about 7? It does? How many times, William? 32? I don't think so. Does 7 go in? Does 7 go in? I don't think 7... does it? It does? How many times? Did I miss that one? I got 15 and 17 afterward. Does 7 go in? Let me see. 7 goes into 25. Does it or no? It does? How many times?
Wait, hold on. Let me do it.
Divide, guys. Huh? 35? Does it work? Maybe I forgot that one. 7 and 35. Really? It doesn't or does it? Multiply it out. Does it or no? Do we know how to multiply? 7 times 35? Does it go in?
It doesn't go in.
Yeah.
Told you all.
Okay. Alright, so so I got 15 and 17 because 8 doesn't. Okay, so which one of these work? 15 and 17. And after all, I'm looking for the difference of these two numbers to be 2. Right? So who could tell me how this factors to Victor?
It's x plus 17 times x minus 15 equals 0.
That's correct. Why do you want, see, you want the 17 to be positive, so you get the difference of positive 2, not the negative 2. Does this make sense? Yes? And of course I can rewrite this as this, x plus 17 times, x plus 17 times x minus 15 equals 0. Would you not agree? Do you see it now? Now, because you know that you have to have 2 in the middle, that means the difference of these two numbers gotta be 2. Right? Because the last number is negative 2 to 5. And 7 doesn't go in, does it? Okay, now, when is this true? In other words, how do I find the solution? This is only true if? If and only if what? Yes. X plus 17 equals 0 or? X minus 15 is equal to 0. So that means, how do you solve for x? You subtract, Lucia? 17 from both sides. The other one you add, class, 15. So we got 2 solutions. Why do I have big red X on 15? Doesn't 15 work? Ethan?
No, it because it's not negative.
Yeah, it's not negative, it's positive. You can't use 15, because after all, I'm not looking for negative odd integer. This is a positive odd integer. We can't use that. So we found our answer. Now, how do I find the other one? Because that's x, that's our first consecutive odd negative integer. How do I find the next one? Yes, sir? You? Where? Yeah, we plug into x plus 2 because that's how you get the second one, which is what? What's negative 17 plus 2, guys? Negative 15? So do you think we have to write the answer in a sentence? Yes, you do. So you have to write. So I wrote down, you need to drop x equals 15. Cannot use that because it's positive. So here are the 2 consecutive negative odd integers, negative 17 and negative 15. Is there a way to check? See if we got the right answer. How do you do this? How do you check? When you plug it in, it should equal to 255, right? In other words, when you multiply these two, do they get 255? Yeah, you could check that, right? You could just negative 17 times negative 15 is better equal to 255. And does it? Yes, it does. Any question? Does it make sense? May I go to example 2? Okay, let's go to example 2. Go ahead and write this down. The length of a rectangle is 6 meters more than 3 times its width. The area of the rectangle is 144 meters squared. Find the dimension of the rectangle. Okay, go ahead and write this down. As soon as I wrote this, somebody said, oh, isn't it 12 by 12? Because, 12 times 12 is 144. Is it right? No, because this rectangle, the length is longer than the width. It's not a square, is it? Because somebody saw 144 and go, oh, isn't that 12 times 12, 144? Yeah, but that's not this rectangle. Yeah, it's not a square, it's a rectangle, right? Because they told us the length is bigger than. Anyway, go ahead and write this down. What are our unknowns here? 2 people? 3? Yes, sir. Benjamin, length and width. Let what? Should we declare let W or let L be the, which one? Let, Ryan? Huh? You want the width, why? Exactly, they describe the length in terms of width, don't they? So let W be the width of this rectangle, then length is what, class? How about, who can tell me the length of this? Rachel, what's the length of the rectangle? 3W+6. Yeah, 3W plus 6. You think it's a good idea to kind of draw this rectangle to help us see what it looks like? I think so. Yes? Now, we're done with step 2. Step 3 is to come up with an equation. What's the equation of a area of a rectangle? Yes. Yeah, length times width gives you the area. So, who thinks they know how to come up with an equation? Go ahead.
3x plus 6 times x equals 144.
Sure, I use W, but you use X. Doesn't matter. So I start off with my formula, right? Length times width is the area of the rectangle. So you multiply them together, it equals to 144, right? How do we solve this, guys? It's not linear equation, so you gotta use the zero product property. Do you know how to do this?
Yes.
Go ahead, everybody try. Let me give you time. Hey guys, I noticed as I was walking around, so a lot of you did this, right? You multiply this out. And you guys try to factor that trinomial. Before you try to factor that whole trinomial, is there something we could do to make our life a lot easier? Chris? GCF of 3. I mean, you could factor that trinomial without doing the GCF, but doesn't it make it a lot easier? Yes? Isn't 3 a common factor of all 3 terms? Greatest common factor? So when you factor out the GCF, you get W squared, 3 times W squared plus 2W minus 48. Isn't that a lot easier to factor?
Yeah.
By the way, we have a constant 3 that equals to 0. Whenever you have a constant factor out and the whole equation equals 0, is there a nice way to get rid of that 3? Just divide by it, right? And doesn't it just become W squared plus 2W minus 48 equals 0, right? So you don't have to worry about that 3 because, it equals to 0. Right? By the way, if you have an expression, you can't just get rid of it. But since we have an equation, right, that equals to 0, you could just divide both sides by the common factor of 3. By the way, could we divide both sides by a variable when it equals to 0? Like, if it was 3x, could you divide both sides by 3x? Hello? No. Then you lose one of your solution. You don't want to do that. Okay, go ahead. Everybody try then. See if this helps, okay? Okay, then, how many ways are there to get W squared? 1 W and W. Okay, what about 48? 1, 48, 2, 24. What else? So you're right, we get 148, 2, 24. Does 3 go into 48? How do you know? You add 4 and 8, and what's 4 plus 8, guys? 12. Does 3 go into 12? Yeah, so 3 times what gives you 48? 16. What about 4? Does 4 go into 48? Yes. Okay. What about 5? No. 6? Yes? Okay. 16. Which one of these works. I mean, we just want the difference to be 2. It's obvious now.